This video introduces the vision recognition strategy for the neatly arranged target objects. It also demonstrates how to configure the relevant parameters using the 3D target object recognition tool. Here, we take the example of ring objects. Typically, in this scenario, the ring objects are regularly arranged in multiple layers, without overlap between layers. The object point cloud remains intact with no significant loss of points. Thus, simply use the 3D point cloud matching strategy to recognize the ring objects. With this strategy, the process of parameter configuration using the tool includes 4 steps. Preprocess the object point cloud. Generate the object model. Configure the 3D recognition parameters. And set the output ports. Now, let's begin the specific operation. Open Mech-Vision to enter hands-on examples. Click 3D Locating. Select the corresponding project and open it. Navigate to the step of 3D Target Object Recognition. Click Config Wizard to enter the tool interface. First, preprocess the object point cloud to filter the interferences and noises, so as to improve the recognition speed and stability. Click Set to enter the 3D region of interest setting interface. On the left visualization area, select the ROI. Adjust the frame to avoid interference from the background, but leave some margins. Ensure that the ROI can cover the target object in the image. Upon adjustment, click Save and Apply. Click Next. Then, generate the object model and the pick point. Click Open Target Object Editor, and enter the target object library. Select the method to generate the object model. Since the ring objects, with regular and simple shape, are easy to recognize, the consistency between the STL model file and the point cloud acquired by the camera is high. Thus, select Import STL file to generate the object model and create the object quickly. Enter the object name. Import the STL model of the object to be recognized. Click OK. Configure the Set Unit parameter as needed. Click Next. Set the pick point. Adjust the pick point pose. In this scenario, we use the internal gripper to pick objects. Thus, the pick point is set at the center of the ring object. At this point, the object model and the pick point have been generated. Click Save. Return to the tool interface. Click Update Target Object. The STL file has been loaded and recognized. Next, configure the 3D recognition parameters. First, set the matching mode. Given the specific features of ring objects, the edge matching mode is recommended in this scenario. To improve the recognition accuracy, turn off Auto Set Matching Mode. Select Edge Matching for the Coarse Matching Mode, and Surface Matching for the Fine Matching Mode. Click Run Step to view the matching results. Based on the results, open Advanced Mode and configure the Fine Matching settings. Select the Performance mode as High Accuracy, and the Deviation Correction Capacity as Small. Please note that such parameters should be adjusted based on site needs. Next, adjust Confidence Threshold to ensure recognition of all properly arranged top layer objects. When setting the confidence threshold, please refer to the recognition result and the recognition report in the visualizing space. Ensure maximum target object recognition while avoiding false matches. In this case, all target objects have been successfully recognized. Therefore, simply set the confidence threshold as default. For the object count output, ensure the maximum output is set to match the number of objects in a full layer. For this scenario, it's set to 25. Then, click Run Step to view the result. Click Next. Configure the output ports. After recognition, there is no need for particular pose adjustments in the scenario, such as the Z-axis orientation adjustment. Therefore, simply select ports related to pick point to output the picking pose. Additionally, for subsequent collision detection, it's necessary to output the point cloud information. Thus, make sure to select original point cloud acquired by camera. Other ports can be configured based on site needs. That's all for the configuration of recognizing the neatly arranged ring objects. The object poses recognized by the 3D Target Object Recognition tool can be used for further adjustments, including coordinate system transformation, pose orientation adjustment for X-axis and Y-axis, and pose sorting. This facilitates the robot to accurately pick and place objects. Further details about pose adjustments are provided in our videos, Pose Adjustment Tool Overview and Application. Each hands-on example in Mech-Vision has detailed documentation instructions. You can refer to the documentation for more operations.